All right, so we are talking about exponential rules and things that you do when you're simplifying expressions that involve exponents. And the very first one is the same base x. Okay, so I've got x raised to some n power and x raised to some m power. And the rule says as long as those bases are the same, we keep that base x, and then we take and we add the exponents. And so that's how I get the x raised to the n plus m. Now, what I do want to say to be careful about is sometimes you might have a question like this. Okay, and instead of putting a variable base, they put a numerical base. And a lot of the times what happens here is people aren't really thinking about the exponential rules. But the rule says if we have the same base, we keep that base and we add the exponent. So if I were to simplify that, it would stay a 2, and then we would add the exponents 3 and 2 together and get 5. We would not change that to 4 to the 5th power. We would not actually multiply the bases. The rule says that we keep the base and we just add the exponents. Okay? You guys remember that rule? All right. The second rule is same thing again, except for this time we're taking and we're dividing with the same base. So we have x to the n divided by x to the m. And that rule says that we keep the base, but this time we subtract exponents, the top exponent minus the bottom exponent. And so that's how we get x to the n minus m power. Now, when we get into some more complicated expressions that we're going to simplify tomorrow, I don't usually do subtracting like that because it brings in the negative exponents and it makes it a little bit more confusing. But I'll tell you again about that tomorrow, how I think about it when we start to simplify. Then the next one, rule 3, it says I have x, some base x, raised to the m power, and that is in parentheses, and it is raised to another power. We call that a power to a power. And this rule says that we keep that base x and we just multiply those exponents. And so that's how we get x raised to the m minus n power. Not minus, times. M times n. Okay, so a power to an exponent raised to another exponent gets multiplied. So far, so good? All right, and then the fourth rule is very similar to the third, except for this time in my parentheses, I have two things that are being multiplied, x and y. And the rule says that that exponent on the outside of the parentheses is going to go to both pieces in the parentheses, to the x and to the y. Now, before I do that, inside my parenthesis, what is the exponent on that x? If it's not written, it's a 1. And what about on the y? It's a 1. So the way that it is similar to rule 3 is that we're taking this exponent and we're multiplying it by that one. So that's how I get x to the m power. And then we do the same thing. We take that exponent and we multiply it times that exponent. And again, that's how I get y to the m power. So if you have a product of things inside parentheses, the exponent on the outside of it is going to be given to each piece of that product. Now, one issue that we have a lot with a question like this would be in a case that looks like this, except for my stuff's not writing properly, so it looks funky. But if I had in parentheses 3x squared and I were to apply this rule, a lot of the times people forget that inside that parenthesis, it is two things being multiplied. It is 3 and x squared. So when I do this, the exponent on my 3 right now is a 1. So this exponent on the outside gets multiplied. So that gives me 3 to the 3rd. And then that one gets multiplied, and it gives me x to the 6th. Okay, so a lot of people forget that they're supposed to square or cube or whatever the exponent is on the outside, the numerical part of that as well. And then I wouldn't leave it as 3 to the 3rd. I would actually write it as 27x to the 6th. Okay, so be careful with problems like that. If you have a number times some variables inside of parentheses, and you have an exponent on the outside, make sure every piece of that gets your exponent. Mm-hmm.
To separate if that other one is, would we ever the x ever be just one? Or would it always be?
It could be a number.
How would you separate the two?
So like you're talking about if it did like 3 times 4 and then the exponent on the outside? Okay. So the exponent here is a 1 and here. So I would do that, which would give me 3 to the third. And I would multiply, and that would give me 4 to the third. And then I would, yeah. Mm-hmm. All right, the next one, rule number 5, says I have a fraction inside a parenthesis, and that is raised to some power. The rule is that the numerator gets that power as well as the denominator. So if I have that fraction, x over y, and that is raised to the m power, the rule says that that m goes to the x, and it also goes to the y, so I end up with x to the m over y to the m. And probably one of the most missed rules with exponent is the negative exponent. Okay, sometimes people confuse this with changing the sign of my base. The negative exponent changes the location of my base, not the sign. It changes the location. So if I have x to the negative m power, then that is equal to 1 over x to the m power. Let me put some numbers to that. If I gave you 2 to the negative 1 power, okay? Is this 2 in the numerator or the denominator of a fraction? It's in the numerator, right? Because it's over what? Over 1. So in order to get rid of that negative exponent, the rule says that I just take that whole thing, I move it to the bottom, and I change the exponent to a positive 1. And then because there's nothing left at the top, okay, so that just gives me 1/2. And this is probably, again, the most missed exponential rule. In our directions, when we start simplifying these, it's going to say simplify. Do not write any negative exponents. So none of your answers should actually have negative exponents in them. Is everybody good so far? Anybody have any questions? All right. Now, if you do not have a calculator, you might want to get one, because the first few of these, I can actually just show you how to do it in the calculator. 4 to the third power simply means 4 times 4 times 4. And if I do that in my calculator, 4 raised to the third power is how much? 64. Okay. Well, 2 should be relatively simple. Anything to the first power is itself. So 8 to the first power is 8. But if you're not sure, guess what? Use your calculator. Do 8, raise it to the first power, hit equals. It will tell you what the answer is. So far, so good? All right, 5 to the fourth power, is 5 times itself 4 times, or we can use our calculator and do 5, raise it to the fourth power, and it tells me it is 625. Those are just basic raising numbers to powers. Everybody good with those? Now, I want to show you how number 4 works, and then I'm going to show you how to do it in the calculator. Now, one of our rules says if we have a fraction inside parentheses and we have an exponent on the outside of that parenthesis, that the exponent goes to both the numerator and to the denominator. So technically, it becomes 1 to the 5th over 2 to the 5th. Okay? Now, if you have my calculator, if you have a different one, I might have to show you a different way. Excuse me. If I wanted to do this in the calculator, you want to enter it exactly as it looks. So because that 1/2 is in parentheses, even though sometimes you don't have to, but if you don't know the difference, you're going to mess up. So open a parenthesis. And then I want you to hit the number 1. Okay, so this is what we're typing in the calculator. We're doing a parenthesis, and then we're doing number 1. And then your fraction key, and if you're using my calculator, it looks like that. You got your fraction? Okay. And then we're going to hit 2. And then we're going to close our parenthesis. And then we're going to raise that to the 5th power. Whoops. I hit the wrong button, sorry. Did your calculator give you an answer as a fraction? Okay, if it didn't, we can show you how to get it there. But what is the answer that it gave us? 1 over 32. Okay. If you did not give you a fractional answer, let me know. I can come show you. You got that right. So you see makes sense? Okay. Some calculators just work a little differently. Okay, so you don't have a fraction piece of it. And then those purposes, is it? Everybody got it on the calculator? All right, we need to talk about number 5 and 6 because they are very similar, but they're also a little bit different. What is, while I'm working on this, what is the difference before the answer? What's the difference in the way the questions look? One has a parenthesis, one does not. All right, so one has what and one doesn't? Parentheses? Okay, so we need to be very careful with this. And if you're using your calculator, you have to enter it exactly as it looks. Okay, but let me show you or explain to you the difference between these two. Exponents touch whatever is directly to the left of them. And so in this case, for number 5, that exponent touches the parenthesis. So what that means is everything inside the parenthesis is raised to the 4th power. And what I mean by that, that means it's -3 times -3 times -3 times -3. Okay. Whereas in number 6, what does it touch? Just the 3. So that means, okay, think about this, and I'm seeing some faces that are confused. If I have -3, can I split that up into 2 numbers being multiplied? I can write it as -1 times 3, right? So with the parenthesis, the -1 goes with me. Without the parenthesis, it is this. It is a -1 and then times 3 to the 4th power. Okay, there's a big difference. The parenthesis says the negative goes with me as I work. Without parentheses, if there's a negative in front, that means I just work and stick a negative on the answer. However, if you're lucky enough to be using your calculator, as long as you enter it exactly as it looks, then you'll get the right answer. So for number 5, I would want to open a parenthesis first. And then I would want to hit -3 and make sure you use the negative sign, not the minus sign. And close your parenthesis and raise that to the 4th power. And what does that give us? A positive 81, because a negative times a negative times a negative times a negative is a positive. And then if we enter 6 just like it looks without parentheses, we do a -3 and we raise that to the 4th power. What kind of 81 does that tell me? A -81. So you have to be very careful with these. With the parenthesis, that negative goes along with you. Without the parenthesis, the negative just goes straight to your answer after you simplify. So far, so good? All right, number 7. What I want you to do first is figure out what -2 to the 3rd power is. Again, if you're going to use your calculator, enter it exactly as it looks on paper or on TV. because that negative is going to go along with it. Negative 2 to the third power means negative 2 times negative 2 times negative 2. If I'm entering it into my calculator, I need to enter it as in parentheses negative 2, then raised to the third power. What does that give me? Negative 8. Okay. And then we're going to do separately 5 squared. What is 5 squared? 25. And then we just multiply the two. Negative 8 times 25 would give me negative 400. Now I have a quick question. How come, if I'm looking at the original question, why can't I just do negative 2 times 5 and do negative 10 and then add the exponents? What's the rule say? What has to be the same in order for me to add the exponents? The base is what we call it. Is the base the same on those? Troy? Yes? Thank you. But does everybody understand the part where I'm saying we can't take and do negative 2 times 5 and add the exponents? The rule says those bases have to be the same, so that's not allowed. And thank you for correcting my 400 to a 200. Is everybody good so far? Now, again, we can't always depend on the calculator because sometimes we have to deal with variables. However, we're not there yet. Now, I want to talk about number 8, and then we'll also talk about how to do that one in the calculator. Again, this is one of the most missed exponential questions, is my negative exponents. If I have 2 to the negative 4 power, I need to get rid of the negative exponent first. Where is my 2? In the top of a fraction or the bottom? It's in the top. So in order to get rid of that, we're going to take that 2 to the 4th and we're going to move it to the bottom of a fraction, which means what would I have to put at the top? A 1. And then I would just actually want to simplify that. 2 to the 4th power. 2 times 2 times 2 times 2 is 16. Is everybody ready with their calculator? Hit 2. Hit your exponent key. Hit negative 4 and hit equals. I got a decimal. Did everybody else get a decimal? Okay, we don't want decimal answers. We want fractional answers. So if you look on my calculator, if you have a different one, I'll have to come show you. Look at the second button on the second row. It's PRB. Do you notice right above it, it says F to D? That means fraction to decimal. So what you can do is you can hit your second key, and you can hit that key, that PRB key, and hit equals, and it changes that decimal to a fraction for you. Everybody follow along? Did everybody get their decimal to change to a fraction? So guess what? As long as it's just numbers, what's going to be real beneficial? All right, go ahead and try number 9. With number 10, you have 2 things that you're multiplying. You would need to simplify each one first and then multiply those. In number 9, I have 1 over 3 to the negative 3rd. So I'm going to do it without the calculator first. Where is my negative exponent in this one? In the numerator or the denominator? denominator. So to make that exponent turn positive, we're going to have to move it to the numerator, which makes it just become 3 to the third power. And what is 3 to the third power? 27. Did you guys get 27 if you did 1 over 3 to the negative third power in your calculator? Yeah. All right, we're going to do 10 piece by piece. I have 4 to the negative third power times 1 over 2 to the fourth power. What is 4 to the negative third power? It's going to be 1 over what? It's 1 over 4 to the third, which becomes 1 over 64. And if I have 1 over 2 to the negative 4, that becomes, remember to make that exponent positive, we move it to the top, which just becomes what? That's not 24, that's 2 to the 4. It becomes 16, right? So in my calculator, I want to enter the fraction. Does everybody know how to enter a fraction? Hit your numerator, hit your fraction key. So we're going to hit 1, our fraction key, and 64. That gives me the fraction of 1 over 64. And then I hit times 16. And that should give me a fractional answer. If I'm not good with that, I can go old-fashioned, multiplying fractions. We go top times top, bottom times bottom, and then we simplify, which gives us 1 over how much? 4. Did anybody run into any issues with number 11? If we depend solely on our calculator, I've been finding an issue with that second piece. First of all, with the first part of it, negative 2 to the third power, what is that? Negative 8, okay. My exponent's not negative, so I don't need to move that. Now, with the second piece, this does have a negative exponent, so I need to move it to the top. That does not change the sign of the number, though. That 6 is still negative when I move it to the top. The only sign that changes is the sign of the exponent, so it becomes negative 6 squared. If I enter that fraction in my calculator with the parentheses, I keep getting an error, and I can't figure out why, so got to be careful with that one. What is negative 6 to the second power, though? Yep. And then if I do negative 8 times 36, I get a negative 288. Is everybody okay with those? Anybody have any questions? Okay, we got to move on to some variables. So calculator is not necessarily going to be our best friend anymore. Everybody ready? Oh, I forgot. We got to add one more rule first, and then we can move on to variables. The last rule that we're going to talk about today about our exponents is a very easy rule. Any number x raised to the 0 power is always going to be 1, except for 0. 0 to the 0 power is undefined. Okay? Any number raised to the 0 power is always 1. Anything to the 0 power is 1 except for 0. That's undefined. I'll never ask you that question, so you don't need to remember it. So if I raised 5 to the 0 power, what would that be? 1, right? If I have, 1 over 2 to the 0 power, that would be 1 over 1, which is just 1. And then for 14, negative 3 to the 0 power is still just 1. Now let me ask you this. What if I wrote that like this? What if I wrote it as negative 3 to the 0 without the parentheses? What would that one be? It would be a negative 1, okay? Remember, the exponent touches whatever's directly to its left. In that case, it raised all of that to the 0 power. Here it just raises the 3, so be careful with questions like that and that negative. Again, that's a numerical thing, so you could also stick that in the calculator. Okay, so anything to the 0 power is always 1. I could give you this big, long problem and put it in parentheses and stick a 0 on the outside, and you'd start trying to work it out, and then you'd see the 0 and be like, oh, never mind. Now we're just going to practice our rules with our exponents, which means we have to know them because our calculators can't do exponents. I'm going to give you just a couple minutes to write these down. We're going to have to go through them relatively quickly. We are going to just do more of this tomorrow, so I don't want you to feel like we're rushing too much through it. For 15, I have x to the 5th times x to the 7th. The rule says if I am multiplying the same bases, I keep the base, and what do I do to those exponents? Add them. Okay, so what is x to the 5th times x to the 7th? X to the 12, yep. So it's x to the 5 plus 7, which is x to the 12. Does 16 look just like 15, essentially? Multiplying the same base. So we need to keep that base. And we need to add our exponents. What do I get when I add 3 and negative 5, though? Negative 2. The thing is, we cannot leave negative exponents in our answers. This is a variable, so I can't just rely on my calculator. I have to know what to do with it to get rid of that negative exponent. X to the negative 2 becomes what? 1 over x squared? Is everybody okay with that? Kind of. We're taking this x right here. It is in the numerator if you think about it. So to make that exponent positive, we have to move it to the denominator. For 17, I have x to the 3rd power, and then that is raised to another power. What does the rule say if I have a power to a power that I do with those exponents? Multiply, so it becomes x to the 12th. All right, I want to skip 18 and 19. I want to talk about 20 just because you might have one of those in your homework. They're all the same type. Okay, so if you guys have 20 written down, just for time's sake. All right, so what we notice is inside my parenthesis, I have a 3 times an x squared times a z to the negative 4th. But I also have all of that raised to the negative 3rd power. So the rule here is that everything that I'm multiplying inside of my parentheses is going to get that exponent of a -3. So right now the exponent on my 3 is a 1. So I'm going to go and do this, which gives, try that again, gives me 3 to the -3rd power, because I'm multiplying those exponents power to a power. Then I'm going to do the same thing with the x. X squared raised to the -3rd is going to give me x to the -6, because we multiply those exponents. And then the same thing with the z. What's -4 times -3? +12. And again, we're doing more of this tomorrow. I don't want y'all to start freaking out. I know we're kind of rushing through it. Am I allowed to leave negative exponents in my answers? No. So what two things have negative exponents that are going to have to move to the bottom of this fraction? Right now it's all at the top. What has a negative exponent? The 3 and the x. So we're going to move that 3 to the 3rd to the bottom, and we're going to move the x to the 6th to the bottom, which makes the exponents positive. What about that z? Does it need to move? No, so it's going to stay at the top. And then the only other thing I would do is I'm not going to leave 3 to the 3rd as 3 to the 3rd. I'm going to change it to not 30, but 27. And then we can't simplify anything because I don't have anything in common.